Let's solve problem F16-24. At the instance shown, wheel A rotates with an angular velocity of omega equals 6 radians per second, and the angular acceleration of A equals 3 radians per second squared. Determine the angular acceleration of the link BC and the acceleration of piston C. So let's look at this. So as this spins this way, it's going to push the rod up. So it's going to cause a rotation this way. And so our alpha and our omega are going to be a positive K. And our VC is going to be, let's draw it over here, VC. So the X component is going to be VC cosine 30, and the Y component is going to be VC sine 30. So that's going to be 0.866 VC, and this is 0.5 VC. Okay, now the same is true for acceleration. I'm going to have an acceleration this way, and it's still going to be 0.866 AC and 0.5 AC. At B here, we're going to have VB, and VB is going to be omega R. So 6 times 0.2, and VB is equal to 1.2. And that 1.2 is going to be in the positive I direction. Okay. So we want to find the acceleration. Now, to find the acceleration in the equation, we would have to know alpha, we'd have to know acceleration at B, at C, we would have to know omega. So having the three unknowns, we can't solve that equation directly. So first we'll start with the velocity equation. So we'll start with VC equals VB plus omega cross RC with respect to B. Okay. So VC is 1.2 in the I direction plus omega, which is omega in the K direction, cross 0.8 in the I direction. Solving this cross product, we get 0.8 omega in the J. So VC and VC, let's break that up. That's going to be 0.866 VC in the I direction plus 0.5 VC in the J direction, and that's equal to 1.2 in the I direction plus 0.8 omega J. So separating the I's, we have 0.866 VC is equal to 1.2, and VC is equal to 1.39. Separating out the J's, we have 0.5 VC is equal to 0.8 omega. PC is 1.39. So omega is 0.5 times 1.39 divided by 0.8, which is 0.866. Now let's write out the A equation. So AC is equal to AB plus alpha cross RCB minus omega squared RCB. And those are all vectors. I should put those up there. Okay, so what is AB? AB right there, we're going to have an acceleration that way of alpha r in the I direction. There is also acceleration down, and that's down, so it's negative of v squared over r in the j direction. So AB is equal to 3 times r, 0.2 in the I, minus v, v is 1.2 squared over 0.2 in the j direction. So AB is equal to 0.6I plus 7.2J. Okay, now putting it into here, AC, as I mentioned before up here, is 0.866 AC, 0.5 AC. So 0.866 AC in the I direction plus 0.5 AC in the j direction equals AB 0.6 in the I plus 7.2 in the j. Then we have to add alpha in the k direction crossed with R CB, which is still 0.8 in the I direction. And similar to that one, this will do the cross product of 0.8 alpha in the j. And then we got to subtract off 0.866 squared, 0.8 in the I, and now let's separate out the i's and the j's, because we don't know AC and we don't know alpha. The rest we have. Okay, so 0.866 AC in the I direction is equal to 0.6 in the I direction. That's J, that's J. This comes to 0.6 also. So negative 0.6 in the I direction, and AC is equal to 0. In the j direction, we have 0.5 AC in the j is equal to 7.2 in the j plus 0.8 alpha in the j. Since AC is 0, we get alpha is equal to 9.